Alright, so we went over the probit and the linear probability and the probit model in the last video. What I'm going to do here is go over the last useful model of analyzing a binary dependent type of regression function, and then also going over some non-binary probability models that gives the output of a probability in the case where we have more than two options. But starting with the Logit model, it'll, just like the name suggests, it utilizes a logistic function. So the lambda of given the average or the chance of the probability happening, it uses the logistic properties of E, and so when we're calculating the integral of the probability given by this Greek symbol here, don't know what it's called, but we have probability of the Logit model given by 1 over 1 plus e to the power of minus L representing the actual regression function. To calculate the marginal effect, we can this is the easier form. I know there's another form of the marginal effect, but simply put, we can subtract the probabilities of 1 unit further of 1 unit between the marginal effects. So if we're trying to find probability of y, the change of probability in y, given that we go from an x variable value of from 1 to 2, then this is what we'll use. Within the L of the regression function, we'll just input a 2 here and then a 1 here. If that's not clear, here is an example of how to calculate the Logit model by hand. So given our previously used example, we have our pass percentage of an exam given by the amount of hours we study. And so if we're trying to find the marginal effect of the passing rate, given that we go from studying 3 hours to 4, then we can just write this regression function here, subtract from here to here. If we study 4 hours, then we're going to have to input 4 here. We get a value of 0.7, so that's what we'll just input within the formula here. 3 hours, this comes out to 0.6, so e to the power of 1 over 0.6. Let me just make that a little more clear, because that did not look like it was powered by. All right. I don't know what this will come out to, but I'm guessing it's somewhere around, it should be similar to a linear probability model, so it's probably somewhere around 10%, but probably a little different. All right, so those linear probability, probit, and Logit model, that's mostly what we use to find the outcome that gives is in the form of a binary variable. So yes or no, just probability of 1 or 0. Whereas we use a multinomial model where our outcome is in the form of a probability, but it's also just not that binary. We can have more than two options. So what is the chance of a student receiving an A in contrast to a B or a C or a D? So stuff like that. We have 3 different types of models to represent that. The multinomial Logit focuses on one outcome for each individual. Now, there are some mathematical notations here, but I wouldn't advise you to focus on that one, because it's not the most clear in the way I've written, and two, it's definitely more important to understand conceptually of what I'm trying to teach. So the multinomial logic will use the maximum likelihood, just like the probit model and then the Logit model. It has what we call the independence of irrelevant alternative assumption, the IIA assumption, which is a very unrealistic assumption because it makes a restriction that adding another option does not change the regression probability that we're focused on. So let's say if we're given by here, this function right here, if it's saying, well, I guess this is an good example because this is a binary, but what's the chance of someone getting an A in contrast to a B or a C or a D, where if we have another regression explanatory variable like hours of sleep or what teacher that the student has or whatnot, then the multinomial logic kind of assumes that doesn't matter, which again is very unrealistic. And so a solution to that is we use the multinomial probit. Probit and logit, kind of the difference being, logit using the logistic and probit using the normal distribution. If you're asking why we would ever use the logit over the probit, I'm not sure. The way I learned it is the probit is just preferred over the logit because of this assumption. And in either case, logit and probit are kind of similar because they use the log properties, the logistic properties. So I don't think there's too much of a difference. We can just use multinomial probit. All right. So for the multinomial logit, we find the marginal effect by with the output being the individual choosing a certain behavior in contrast to in respect to the probability of an individual choosing a specific behavior. This being more general, written by J, and then this being considering that the individual chooses a specific option that we call option 1. And so in result, again, we get a log property where we take e squared by the regression function, or to the power of the regression function. And so that's a probability ratio. If we're finding for how much more likely it is for an individual to choose option J in relation to the first option, when we're comparing options, then that's when we use the partial derivative of this probability over here in respect to x. All right, now the conditional logit model is different from the multinomial logit and the multinomial probit because it actually accounts for both the individual and the choice variables. So when we're looking at this, we're only looking at one outcome for each individual. So right here, we were kind of looking at only if the individual chose option 1, then what would our probabilities be? Whereas in the conditional logit, we don't have to say our individual chooses option 1, then what will happen? We kind of just kind of generalize it up, sum it up in one regression, saying and focus on what would be the effect regardless of what choice our individual chooses. So we're not comparing our individual choice from one to the others. We're just saying what is the general function of these individual choices, these behavioral differences determined by different individuals. So I would say the conditional logit is more general, while the multinomial logit is more of a specific case. Like if we're comparing the base to something to like all the other alternatives, while the conditional logit is a more of like an overview, more of where we don't know where to start, so let's just take the regression of everything. All right. Finally, we have what we call the order probator logit. It's kind of similar to what we've done here, except we're basically assigning values based off of a consistent system. And so if you've ever done like surveys, if you've ever done surveys, we can, measure our decisions by saying if we strongly agree off of an opinion, then we'll assign a high value to that. If we strongly disagree, then we'll assign a low value. So if you've ever wondered like how MBTI characteristics are measured, that's probably how we would measure it. But similar to every other type of survey. Obviously, just like every other type of regression, we have errors to account for, what we call the unobserved information errors. So in an example like this, if we think we strongly agree off of an opinion, but in reality we're kind of more neutral and agree to it, but we choose strongly agree just because we have emotional reasons, we have emotional attachments to it, or we maybe off of a recency bias that happened to you like yesterday or recently. That's what we'll call the error of sentiment caused by the emotional response. And the way we determine that is called the latent variables. I don't have the algebraic formulas or how we can analyze the latent variables using the latent variables, but that's what we'll just call it for now. Like I said, these lectures are based off the class I took in college, and we didn't go over how we can use the latent variables to distinguish these sentimental differences. But if you want to go into further, I'm sure you can go into GPT or Google or whatnot. But that's all I have for the Logit models and then the multinomial models. That's pretty much it so this is the ninth video I've covered over this 104 series, this multivariate regression. And so that's all I'm gonna do. That's all the lectures I'm gonna do for this series. In the next few videos, I'm gonna go over these software applications, to how all this can be applied using real example data sets. So if you've ever thought like all the stuff I was doing is abstract, then I'm basically gonna try to prove you wrong. I doubt you think that, but I'm just gonna go over real life applications, real data set examples of how we can apply this. The real hypothesis test we use for all of the time series, the endogeneity, the random fixed effects, all of linear probability, all of that. All right, but this is the last like chalkboard lecture for the multivariate regression.